Hey everybody, my name is John Allspaw, and I am super pumped to give this presentation today about my favorite topic. So the title of the talk is important here. So hard problems we handle in incidents but aren't often recognized. So what's the story here? What am I on about? So here's the story. Obviously, we're at SREcon. I think that this crowd intuitively understands what I'm going to be talking about, but I want to take you a little bit on a tour of some of the types of challenges and trade-offs and paradoxes that we face when we're responding to incidents. When you all are responding to incidents. But because you all do it pretty damn well, we don't tend to notice these sort of challenges. They just come with the territory. So my goal for the talk is to convince you that phenomena like what I'm going to talk about exist. That's the goal. And that it's valuable to identify, explore them, and have some vocabulary for it. So I'm going to challenge you here for a second. I'm going to ask you to temporarily take off your engineer hat and put on your explorer hat, okay? As we walk through some of these, I don't want you to think of solutions. I don't want you to think of these as problems to be solved because, frankly, a lot of them are not solvable. They are helpable. They are things that you can improve at, but they're not solvable, really, okay? So first I want to start with this. If we look closely, we can find all kinds of different activities that people are engaging in, right? As they're responding to an incident. An oversimplified view is what we normally think of as this age-old, well, first you detect something and then you diagnose it and then you resolve it. But of course, reality doesn't follow that. There are no crisp lines or boundaries. What I'm showing you here is something from a pretty old paper at this point, and it does a pretty good job of capturing how various, not really categories, but types of cognitive work that people are engaging in, and together with their teammates as they're trying to work out what's happening in an incident. Okay, so that is a bit of an abstract model. I think we can get a little bit more descriptive. So I'm going to lay out 4 different types or sort of buckets, let's say, and of activities. And we can take a peek inside each one of them to maybe get a bit more concrete on what people are actually doing during these incidents. So diagnostic work, let's start there. It's aimed at answering questions like, what's happening? How is that happening? How did it get like that? What will it do next? So obviously there's a lot going on in here that we often work through pretty fluidly, even though questions like these don't have easy answers. For example, what tools could I use? What tools am I familiar with that I think would be appropriate in this particular case? What tools are others already using? What observations should I share with others that I'm making? Oh, look, CPU looks actually fine. Maybe I should share that. Or maybe that's pretty obvious. Do I need to explain what I'm sharing as what makes it interesting? And how much detail? How much attention should I pay in general to what I'm doing versus what other people are doing and sharing along the way? Therapeutic activities are things that people do to help the situation. What can we do? And what are we able to do? These two things might be quite different. And so what do I mean by what should we be doing? What action should we be taking? Well, sometimes we want to lessen the impact or somehow stem the bleeding, prevent it from getting worse. Or sometimes we need to just shut everything down or stop a particular process while it's happening And in that way, I might actually sacrifice some data, some diagnostic data that might help us. In that way, we might actually take an action, even though it could, by doing the action, prevent us from helping or understanding what was actually happening. Or might just have a good idea about, oh, we should just do this thing to fix it all. So in all of these cases, in all of these actions, the question can be, what options can I see that I think might be productive? Or what options are others proposing? And there's, again, quite a fluid interplay between these things. Another sort of bucket of activity is having the right people, because of course all the right people don't always show up magically to incidents where they're needed. There's work in calling on people you need during an event, and we'd call this recruiting activity. Folks tend to be called for skill or expertise that they have, or maybe even authority that they might have. So, for example, what expertise does the group have? I've got Lisa and Joe and Phil and Raj and Steve, and what do I know that they know about what's happening? If I have a good understanding, I could figure out, or at least have a good guess at, what expertise do we need that we don't already have? Let's say we already have all the expertise we need. What authority does the group have? We might have good ideas about what to do. We might not be able to actually make that call. Therefore, we may need people to be able to make that call once we give them some context. So for both of these scenarios, who do I know who has this needed expertise or authority? How might we be able to call on them for help? Do we have to page them? Are they available? What do they need to know once they show up? We're going to have to give them some background. And this leads us to the last little bit here, which is status reporting activities. Now, as it turns out, there's responding to the incident and there's updating others about the incident for some reasons. These are not the same thing, even though we like to believe that they are. And like the other activities that we were talking about, we can find a lot going on when we look closely. So, for example, which individuals or groups need to be informed about the current status or the current state of how we're doing, of the response. This is different than what individuals or groups do I have to be, do want to be informed or need to be informed about the potential effects of the incident. So, for example, customers or internal consumers of a particular service that are having some issues. In both of those cases, how often do they need to be updated? What level of detail do they need? And who's actually going to be doing it? Turns out to be pretty difficult questions depending on the case or the incident that we're particularly handling. All right, so now that I've painted a little bit of the landscape of what actually happens in a lot of incidents, I want to talk about a couple of specific phenomena that happens. I'm interested in if any of you see in these similarities to experiences you have. So the first one I want to talk about is really more of a collection of activities that all have some sort of cost associated with them. And so these are referred to as the costs of coordination. I'm going to talk about a couple of them. Before I do, I want to make sure that it's quite clear. Think of this as not even Cliff Notes. This is going to be a surface level treatment of the topic of cost of coordination. If you are at all interested, and you should be, then what you would do is go and look at Dr. Laura McGuire's PhD dissertation. Her dissertation was on this exact topic, controlling the cost of coordination in large-scale distributed software systems. For convenience, this is what it looks like. Don't complain about having to read. You're reading code all day, so zip it. So All right, so let me describe this to you. So as an incident response, right, evolves, it can draw in more and more people, right? And as it does, managing all of this and all of these folks in and of itself is a challenge in addition to the response to the incident, right? Some people, when noticing that they have an outage, think, I know, I'll call lots of people. Now you have two problems. So these folks responding to the incident face a little bit of a quandary, right? So on the one hand, people joining the response could be a huge boon, right? They could be a major source of expertise that might speed up diagnosis and generating options to do and repair. And on the other hand, the effort needed to bring them up to speed with what's happened and what needs to be done or what's possible to be done takes attention away from going further in diagnosis and repair, right? So if Stephanie is, everybody knows Stephanie is the Postgres, expert, and you've been working through this issue, didn't know it was a database issue, and you get pretty far, and you realize, oh crap, this looks like a Postgres situation. And so, all right, well, of course, everybody knows, let's call Stephanie. And you call Stephanie. Well, are you gonna, let's say Stephanie gets on and she's in Slack with you or Zoom or whatever. Are you gonna tell Stephanie in high verbose ways exactly what everyone did thus far? No, you're going to summarize. You're going to pick a thing that you think is going to be important for her to know, and you're going to tell her that. And you're not going to tell her things that you think she doesn't need to know in order to be productive and helpful. This is a trade-off. So, in other words, option one, should the people responding, should they say focused on this incident in order to maximize their chances of diagnosing or quicker resolution, or should they devote some of the effort and the time to bring others up to speed? Remember, the amount of time that you're bringing others up to speed is time you're not spending on the incident or preparing for other options that you might think you might need in the future in responding to the incident. Like, for example, restoring from backup takes a lot of work to get that all set up. Quite often we'll see in situations that when people think that they have to restore some database from backup, they might say, all right, Raj and, Phil and, Stephen, you go work that out. We're going to continue this. We might not need it. We'd rather have it. So get working on it. Now, I want to point this out. No matter what sort of incident response framework anybody you use, this trade-off space exists. I'll say it again. ICS or no ICS, judgments have to be made. The question is what influences those judgments about these types of trade-offs. So another aspect, another sort of facet is that, and this is what was found in the Stellar report, I think I linked to that a little bit later, this approach of divide and conquer, parallel streams of activity, sometimes people call them swim lanes or whatever, assigning tasks to someone else also bears a cost. So let's say you're coordinating the response and you say, hey, Phil, can you check to see if the config in something mumble is okay? And Phil says, yeah, right, I'm on it. Okay, great. So this happens a lot. I'm going to go do this, or in that case, Phil might volunteer. Oh, hey, while you do all that, I'm going to go do this other thing, and I'll come back, let you know what I find. This is what I mean by sort of invisible, really. So on the one hand, in this case, Lisa is here in the yellow. The benefit to Lisa is that she can do a bunch of other things while Phil works on looking at the config or whatever that task is. But there's some costs, right? So the first is that Lisa's got to know what can be done. There's checking the config versus some other myriad of things that needs to be done. So identifying a task that you could delegate and having a rationale for that, you've got to do that. You've got to select somebody to do it, and you've got to at least specify what's to be done. Now, in this case, she's just saying, can you check the config is okay. I have no idea what that means. Maybe Phil absolutely knows what that means because they work together or it's contextual to the incident. But Lisa's also got to, now if Phil is, says, oh, I'm on it, and then takes off and you don't hear from Phil again, Lisa still has a thing in her memory stack, which is she's either expecting Phil to come back, or if he doesn't come back within the time that she's expecting, she's got to go find him, right? And so it may seem like not that big of a deal, but these are the things that can stack up. So it only makes sense to assign tasks that are well bounded. That is to say, in this case, that config is okay. Or can you check to see if all of the new columns have indexes, or check to see if all the nodes got the recent release, or whatever. It has to be specific enough, or enough common ground between the task delegator and the task taker that they understand each other. You can't delegate something to an individual, a thing that an individual cannot do themselves. And so that influences what you're going to assign people to do, or what they're going to volunteer to do. It only makes sense to assign tasks that are for which a suitable person is both available, and this is the key part, and not already working on a higher priority task. It may be absolutely true that Phil's absolutely the right person out of everybody there to check to see if the config is okay. Phil also might be working on something already, and this may represent a damaging context switch. Okay? I think you're getting the sense about these not being solvable problems, just descriptions of them. There's another catch, last for this gamble. Shifts in the pattern of failure may make doing a particular task unnecessary, right? Or even hazardous. So you say, let's say Lisa says, oh, hey, Phil, can you, can you bounce NGINX on something cluster? And he says, okay, good. And Phil's off doing the thing, and Lisa and her colleagues work out actually bouncing NGINX on that cluster actually might be the worst thing that you could do, actually. So please don't. And so now you've got to go and work out how far did Phil get and that sort of thing. This imposes additional workload on the parties. Like I said, I don't want you to take my word for it when it comes to cost of coordination. The Secret Lives of SREs, Laura McGuire, last year gave a talk on this topic. Add my tiny little ramblings to the smart and clever things that Laura gave you all last year. If you haven't seen it, it's worthwhile. Okay, so here's something I want to, the next little bit here is called sacrifice decisions. And so a sacrifice decision is when during a disturbance, achieving important high-level goals may require abandoning less important or low-level goals, right? Sometimes a sacrifice requires incurring damage, even severe damage, in order to prevent an even greater catastrophe. So, what does this mean? This is from the Stellar report, and there's a good deal on there. What are examples? Forcing a network partition to allow recovery, for example. Killing slow-running database queries until they can be fixed in code. These come with a cost. Reducing or even eliminating cross-data center encryption mechanisms temporarily to relieve replication lag. We've seen this in that. On the one hand, if you reduce or get rid of encryption, which is the thing that's busted, things will start working again. The downside is now you don't have encryption. So another example of a case that included a sacrifice decision. On the morning of July 7th, 2015, engineers at the New York Stock Exchange began detecting some signals that the trading platform was not behaving in the ways that they expected, right? It was unclear what was happening, but something definitely was happening that concerned them. So when the CEO of the exchange was made aware of this, he said, shut it down, right? Instructed them all to halt the trading and the platform until they can work out what was happening. And about 4 hours later, they managed to become confident enough to resume trading for the, well, little less than an hour left in the trading day, okay? When Bloomberg reporters asked the CEO for comment on the incident, he said, my first concern was do no harm during the day. Those stocks continue to trade elsewhere, get the problem fixed, and get it back up and running for the close. We chose the least disruptive option for customers. So when he decided to do this, in other words, rather than risk production trading traffic being adversely affected by this unknown anomalous weirdness, he decided to halt the system, even though doing so risked drawing some significant criticism, and indeed it did. So sacrifice decisions like this are effectively choosing between multiple crappy options. They tend to produce these sort of lose-lose situations, and they almost amplify hindsight bias, right? Bringing people outside of the situation to judge the decision harshly, right? If the CEO didn't shut it all down and stock trade data were somehow corrupted or out of sync, he'd be absolutely roasted for not protecting against that, or maybe even investigated by regulatory bodies. If he did shut it down, he'd get judged for doing that too, which is exactly what happened. So having to choose between those options that all have downsides is something that happens more often than we acknowledge in SRE work, and it happens in incidents. So this brings us to sort of the last little bit, the last phenomenon that's weirdly specific, but also super fascinating for me. So to be fair, we could think of this as a special case of coordination trade-offs. So parallel incidents, right? So if two incident responses that are happening in parallel are related, then combining efforts and observations across the two groups that are responding to the incidents could be really helpful. And it could also be super productive for both of the groups, okay? If the two incident responses are not related, then investigating if they were related could be seen as a waste of time, right? Wait a minute, incident 1, 2, 3 is happening. Did you know that? Well, we're on incident 4, 5, 6. I wonder if it's the same thing. Their thing has something, something, and we have something, something, so maybe they're related, we're not sure. Should we spend time figuring that out or not? So how could you discover if another incident in the first place is even happening at the same time yours is? If you do discover that there's one is happening, how could you tell if the time or effort spent determining if they're related is warranted? So this is a dilemma. I want to describe an actual case, and I'm going to give you some sort of visuals here. These are made up as sort of completely unrelated, but you can see this as a sort of a chat transcript of some sort of people trying to work out what's happening. So what I'm going to do in this graphic, in this sort of visualization, is I'm going to pull out the actors, right, who are sort of working through a given incident, right, and what I'm going to do is I'm going to lay out a timeline, right, sort of horizontally. Get it? Okay, You see what I'm doing here? So there's, Steve and Lisa and blah, blah, blah. So this is some data of a case that we've analyzed and along with one of our clients. So there's this incident and it's happening. Yeah, didn't seem like it was a melt the world catastrophe, but it was definitely something worth paying attention to. And so it had gone on for a little while. And somebody says, it works out that, maybe there might be related to a change that was made recently. And so it says, hey, person that you, in this case, Steve, can you shed some light on what's going on here? It looks like it's related to this thing that you, and Steve says, oh, yeah, well, there's a pull request merge this morning. And so, okay, I'll take a look into it. And so some time passes there. Meanwhile, what had happened was a completely separate group saw this sort of anomalous, sort of weird behavior and spun up an incident because they're responding to it. And the first group wasn't aware that was happening. At some point, somebody said to Steve, somebody else who also knew Steve was somehow related to a change that was made that they thought could be suspect, said, hey, you might want to go look over there. So Steve jumps into this other channel and says, hey, just want to let you know there's this other incident going on, and we're pretty sure that there's this thing, and so we're trying to work out how to clean it up and that sort of thing. And so some time passes, and both of them, the second one sort of like, okay, I guess we're just going to wait a little bit, or they had some other things to do. Some time passes. There was a third event. And when Steve was aware that the third event was happening, jumped into that one and wanted to be helpful. Like, hey, this is what's happening. Look, I see what you're doing. I'm in 2 other incidents, and it's very related. And so this is what's going to work out. And so they ended up, working out with it, and it resolved. So this sort of thing happens. I'm very curious if that's ever happened to you, that parallel incident dilemma. I want you to hit me up in the SREcon Slack or Twitter. Tell me if that was the case, if you've seen that before. So I've given you some of these to think about, right? I want to talk a bit more optimistically. And so why am I doing this? Well, the first is we are way better at this stuff, handling these, than we think we are. I just gave you a description of pretty tough problems, like I said, that aren't really solvable. But we're really good at it. And it's difficult for us to see what makes us good at it, and that's the flip, right? Here's the thing, the most beautiful, amazing, incredible thing. You are why your services stay up, why things actually work and stay working. That's because of you all. You all are the sources of resilience. It's not the load balancers, it's not the designs, it's not the distributed blah, 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 blah. And yes, there are definitely conditions and influences that make it harder or easier for you to do this work, but absolutely make no mistake, it is you, it's all of you. And so perhaps the real challenge, maybe poetic challenge, is understanding how you actually do what you do. And the wild thing about expertise is that we don't know when we have it where it comes from. Can't really be concrete. Experts are not necessarily expert at understanding or describing what makes them an expert. Expertise is more invisible than we realize. 1966, Michael Polanyi, he was writing about tacit knowledge. He said this, well put, we can know more than we can tell. And that's absolutely true of SRE work. It's having a vocabulary for these phenomena is important, right? When we've got words for them, we should use those in our stories. Stories are what makes us as good as we are. It's not just about our individual experiences. So I don't think I've described anything exotic or novel here in these phenomena. I'd expect everybody listening to have stories that include some of them: cost of coordination, sacrifice decisions, these parallel incident dilemmas. These are some terms we could use to describe our experiences to each other. And that's what's important. So that's what I came to say today. And I hope it generates some good discussion, or at least skepticism, as long as you express that skepticism out loud. So thanks a lot for listening to my talk. I appreciate it.